This precise component will give the robot's joints their movement. This board will be the robot's brain, processing sensor data and controlling movement. These sensors will let the robot see and navigate its environment. Human precision meets robotic engineering. Here at the assembly line, the outer shells are carefully fitted, bringing the machines to life. With the neural cables connected, the robot's optical sensors activate, a defining moment in the build process.
Look at that correction. The stabilizers are holding.
It's walking. We actually did it.
We are currently at 47,832 cycles. We expect this joint to last for years in the field. This tests the robot's ability to see and understand its environment, critical for real-world function.